of the incline. I'm going to throw a ball here. Let's take this point. Yeah. Now, say this is going to go like this and will strike. Sir, how do you can draw such diagrams? Okay, shall I draw like this then? Or shall I draw like this? First it'll go, then. Quite natural. No, let me throw the ball. Let me stand at the lower steps. I'll throw the ball towards so that it should strike the upper step. The path will be parabolic. Sir, are you sure? From my side, I'm saying I'm very sure. Your side, you are not sure? Okay, go and verify it. These are things. So now G, we have to resolve G. So let me show that splitting up G here. So this will be the G sine theta or G parallel. G perpendicular. So what is G parallel? Should be resolving of vectors G sine theta. This will be G cos theta. Similarly, resolving the velocity component. I'm projecting this with an angle alpha. So the inclined plane, what is inclined plane? This is inclined plane. What we are doing is like, I'm projecting that. So, sir, can I project normal? As if you project it, say, I think some, once again, you must have certain things. If you project normal, how do it will move? The two trajectories is what I show it. Which one use? Shall we go for the one or two? Definitely two. Sir, how come? Yeah, G will act here, no? Say, whose help you have to take it? G. Because the velocity and acceleration should deviate away from velocity. Yeah, this is correct. No, here. How come it will go like this? Sir, what's wrong here? It will deviate here also. It should deviate the resultant velocity vector. The path should be between the velocity and the force it is acting. It should not be in this side. Not possible. It should be deviate in the resultant path. The resultant of these two will be somewhere here like this, no? So it is going to come here. Okay, fine. So it cannot be like this. This is not possible. So later on, I'll come to this one. So have a general idea. I'll keep it. Okay, we'll proceed now. So now U parallel, U perpendicular. So this will be U parallel. This is U perpendicular. So what type of motion? It'll describe. I'm projecting from A. So it'll go and strike at point B. B perpendicular. Just some call came from college. I'm going to project it up the incline. Then V perpendicular, this will be a V parallel one. With respect to horizontal, you can define the alpha plus theta with respect to horizontal. You can do horizontal oblique projectile problem also. Let me do up the incline this one. Let's write all the things. I'm projecting up the incline. So first we have to calculate the time of flight. So it will take some time t to reach here. And time t by 2. Then let's go for the range. How do we can calculate the range? Okay, the range is equal to, first we'll calculate the time of flight. Displacement perpendicular to incline should be 0. So this should be equal to u perpendicular t minus g perpendicular t square by 2. U perpendicular is u sine alpha. T or will have some. So t is equal to 2u perpendicular by g perpendicular. I need a lot of space. Okay, finally, this should become equal to u perpendicular is u sine alpha. G perpendicular is g cos theta. Keep it in hand. Okay, let's calculate the range. Range along the incline. Range along incline. I think it's a very specific here, along incline. This how to find out this one. Range is equal to, this will be u parallel t minus g parallel. Sir, what is this? Why you are bringing negative sign? The g parallel is acting opposite to u parallel. Look at here, these two. G parallel is acting opposite to u parallel. So therefore negative. Why r is positive? You are measuring the range along the u parallel. So therefore this is positive. I think substituting all this, we'll get expression for the range. U parallel. Where is the u parallel? U cos alpha. G parallel will be g sine theta. To u, okay, this will become. Yeah, we'll leave it, I think. Okay, there's a range like this we can find out. What about the velocities? Let's have that one. V perpendicular should be again equal to u perpendicular here. I'm writing directly. Here also the same thing. What about V parallel? U parallel minus G parallel T. So what do you expect the final speed? V parallel square, V perpendicular. Will it be less than u or greater than u? V will be less than u. Then we have something like x1 and x2. Anything about x1 and x2?
That is x1 is greater than x2.
X1 must be greater than x2. Then it will come and strike at an angle. What can be this? Some angle phi, I'll write it. Phi and alpha, will it be equal? So some, okay, let's go for tan phi is equal to V perpendicular by V parallel. Definitely, they may not be. All this data is needed. So a student must have a basic general thing.
Sir, always V perpendicular will be equal to U perpendicular.
What do you mean by always, Ma? Why you are saying always? Why you want to say in inclined projectile only? The two point of projection and point of striking lie on same inclined plane. Okay?
Okay.
Sir, in the projectile down the incline, the first page, sir, that time, sir, can you scroll the page, sir, once I have a doubt? Sir, yes, sir. Here, angle of inclination and the angle of projection and angle of inclination are same, sir.
It happened, no. Like I don't know mathematics, you don't know maths, geometry. Huh?
Okay, sir.
This also I should tell.
No, sir. Because here it was not equal. That's why I got clarified. Got
Okay.
clarified.
Yeah. Making observations, see, very essential. See, nothing, don't blame me because I'm assuming that you know all these things in high school geometry.
Sir, can you scroll down?
We are here, projectile up the incline. At what height it will strike the incline means he's asking this. Can we calculate this h? How to bring this h into picture? So here I'll give some separate diagram. This is A, B, this is H. So somebody will trouble you with these things also. This H is what I'm asking you now. Now we know this is R, so sine theta. So what is H equal to? R sine theta. We know range. At what height from the ground it will strike the inclined plane. So what is H? You can how to define H? The height at which the projectile projected up the incline will strike the inclined plane from measured from the ground. This H is measured from the ground. This is the ground, no? They may trouble you. Instead of asking range, they'll ask you H. So if you know range from there, we can bring the H here. Several things can be asked. So just be ready for all the possible things here. I'll remove this. It will become a little bit for you. Yeah. Okay, let's analyze. What is the condition for the projectile to strike normally the inclined plane? It can happen that it may strike normally. Sir, what do you mean by normally? V parallel may be 0. So there are three possibilities are there. V parallel, non-zero, or can be 0. And V parallel can be positive or negative. V parallel can be down the incline also. First, we'll make it where there's a V parallel non-zero is what you are seeing. So if V parallel becomes 0 means how did it strike? It will strike normally.